give a toss. My preview is 5 minutes behind. Oh, we're live again. Oh, there we go. Christ. Right, I'm very liable to be interrupted by phone calls. I don't understand the new YouTube studio. It's very, very confusing. My apologies if everyone's gotten like 5 notifications about this stream now. It's going to be probably divided up into 2. It's frustrating, but we move along. But yeah, I'm probably... there's a decent chance I just have to run away soon to take care of stuff regarding another part of this machine. Oh God, do I even have... Oh no, the chat, I'm quite sure the chat's broken. Oh, the chat's not broken, good. Well, hello to and welcome to part 2 of this thing then. We're just going to keep on working, no time for introductions. I really need to get this done tonight. So what we were doing before we got interrupted was just walking this capacitor out to replace it with another one. And there we go. We did get one pad with us there, but and we also got a pass through. That's annoying. Ewan Murray says, could you give us a quick recap of what's happened thus far? Not really. I did a long info thing about what we're going to be doing, but I don't have time to do that. For the time being, we're just replacing part of this board, and then we're going to be installing a modification that that's going to be like we're going to be mating an optocoupler to the middle of the backside of this board to give it some feedback on a thing, but I really don't have time to explain it. I'm sorry. I'm in a bit of a hurry on this now. You'll just have to see what happens as we go, I suppose. But for the time being, we are just replacing capacitors mostly. Going to be redoing some solder joints, general old device maintenance. General old device maintenance. Petronic says, please tell me what this is about. We are... Well, I just said most of it. We're swapping parts on this. We are renovating this board. We're putting new fresh capacitors on because it's 40 years old. And then we're installing an optocoupler circuit to enable us to have a closing relay output for when a specific pin goes high or low. And that has to be on a separate power supply from the actual signal. So there's a bit of trickery in that. If I don't have to disappear, it's probably going to be a reasonable long stream. This stupid thing does not want to get evacuated. So that's one capacitor removed. Now let's do the other one. I ended the stream because it's really I ended the last stream, the one we were just doing, because I was fairly sure I was going to have to just leave right then and there. But it seems if I'm going to have to leave, it's going to be in a bit rather than right away. So we're going to give it another go. So now we are walking out another big capacitor, you can see it here. And we can't desolder it because it's a snap-in. So it's impossible to not get very big sweat joints trying to evacuate these holes. So the only way to remove it is to just heat it and slowly wiggle it out, which is a bother since it's a 5-legged capacitor. Ah, what a fiasco. There we go. It's removed. We did not pull a pad mat on, so that's good. A fair few people are showing back up. Hello, apologies for splitting the stream. I thought I was going to have to run away, but it turns out I didn't have to run away. Yet. I still might have to leave. I'm very liable to get more phone calls I have to tend to. So be advised, this might get cut short. I feel really bad about the guy that did a super chat and then I just take a phone call and run away. I hope he's found his way back. Well, that's a sad cow. A sad cow disease. Just have to empty my mag. My filter is getting quite nasty. Malatil says, hello, good evening. Hello, Malatil. Welcome to the stream. Stream número 2. Attempted stream número 2. Oh yeah, let's get our picture of a board back on the screen. There we go. So now we are going to install the 2 jumpers to the left. Or rather, we're going to clean the board on the top side and install our new capacitors. The reason to clean the board here is because I know the old caps, they leak slightly and they tend to just kind of want to start dissolving the boards if we don't wipe it off. Yuck. So the new caps go believe it's positive and positive, and the negative then is jumpered. Sky Wizard has donated another £10. Long time no see, Happy New Year, he says. It's a bad time to be giving me money because this stream might be cut short. Because I might have to run. So since this is a big industrial thing, important to glue everything down so it doesn't just rattle itself to pieces. It's fairly sturdy, but I like to. Go the extra step. With these 5-pin caps, usually only 2 pins are used. Snap in caps with the wrong pin spacing require lots of force to go in hole. I think this one hole might not be completely evacuated, so we're going to give it a bit of heat and a push. Yeah, that one well. That's in place. Larry says, looks like this is older than he. This is older than me. This is about 40 years old equipment. And it's ready to last another 40 years once we're done with it. Malteal is asking, is this glue easy to remove? Relatively. It's by far not a bad glue to remove. What the hell? My windows are teleporting around. What? No, stop. Zoom, please. So we have a few jumpers and cut traces here. But we need to work on. Yeah, so we want to jumper this over there and this over there. God, I really hope that I don't get another phone call tonight. I don't want to have to go troubleshoot this machine tonight. I want to do it tomorrow. I'd rather not troubleshoot it at all. So I'm bending a jumper to fit just right. There we go, beautiful. it in place over here for starters. And take the end with a capacitor later, so we heat the cap as little as possible. Because the less you heat the capacitor, the happier it is. If we solder that end first, we are preheating the copper, so it doesn't sink as much temperature. There we go. Need a bit more solder on that just to get it to wrap around completely. There we go. Jumper number 1. Now let's see. We can do jumper number 2 there as well. And we also want to jumper scratch some off there and the jumper across to this track as well, because that's bringing ground to over here where we actually want to ground, because you can see on the illustration we have you can probably barely see my mouse point, but this is actually cut over here, and that's because of a wrong ground. So we're taking ground over there instead by jumpering it, so we need to cut the track over here, and we also need to cut the track over there. I think these grounds are switching places basically. So let's get some sharp blades and get under the microscope and start doing the cutting. Where are we? There we are. This trace is going bye-bye. We need you no more. These bolts are very thick, massive copper. Very high quality. Sploink. No more trace. And we also want to cut it over here, because this is the wrong ground. I hope the guys over at the printing press are getting this shit sorted, so I don't have to go there tonight. I don't want to go to the printing press tonight. I've already been there once. That's enough. I just want to stay here and get this board done. God, look at the thickness of this copper, it just keeps coming. That's one of the cuts. That's the second cut. I think this is going to pop out nicely now. Beautiful. What's happened to my camera angle? Neuronal Axon says it's always Dremel time. It's never Dremel time. I don't like Dremels. They just make such a mess. Neuronal Axon also asks what are we looking at? This is a power distribution board from a brake controller in a printing press. This is a board that makes sure that some very big rolls of paper don't spin out of control. And we are installing some modifications to this board to get it to last into the new decennium, the new millennium, the new century, and the century after that. And I was stupid to solder this because we're going to have to desolder that to get our next jumper installed. So let's get a crappy blade and scratch. There's some copper off here. And we want to jump this over there as it looks. Over there. So I want to strip this so that it can go through the hole. Through the hole, over there, and turn on to there. So we want like that much-ish. I want to strip it from there onwards. Well, that's not worth much. I want to bend it down so it makes good contact with a pad, and bend it flush and bend it to the side. Pretty much a 90-degree turn, that should be good. Yeah, not quite a 90-degree turn. Beautiful. As long as we scratch some more copper off, there's some more solder mask off, that can be fine. There we go. Can I move stuff around so I can actually see the chat? There we go. Wonder if any of .var. Okay. Right. Solder one end. Solder the other. Lots of solder on that. Beautiful. So now we need the green jumper wire. So we want to scratch a bit of solder resist off of that. All of these weird cuts and things, let's see. This cut is actually, this is the signal for the relay we are using to monitor if this board is active or not. And it used to be controlled by this connector. It doesn't need to be controlled by that connector anymore. Oh no, hang on. No, sorry. It used to be, oh yeah, it used to be power supplied by this positively to this capacitor, but that's the wrong power supply right now. So we're getting a power supply from over here because we have two different 24 volt power supplies, maybe even three actually. But we're changing the relay that's all the way over here to be powered from this 24 volt rail rather than this 24 volt rail. That's what we're doing. And we need some green wire. We need that much of it. Neuronal Axum asks, I wonder if any of the components are date coded. This board was made in 1989, so this is actually one of the newer ones. There are boards of these dating to the late 70s. And I think the fisheye thing on this camera is not doing us any favours right now. I think that's more useful. Crotch camera, but oh well. Completely overexposed crotch camera, but you can see what I'm doing. Someone says title is wrong. What's wrong with the title? Since this is the new YouTube thing, I don't know what my title is. I know nothing. actually going to suck off the old solder from there. Neuronal Axum asks, I wonder when the board itself was designed. It's a late 70s design. I think they got the printing press with the system in 1979. And tweezers, pokey. There we go. So now we've successfully copied the thing on the left to the thing on the right, except we've got different color wires. That's all right. Melital says 1989. Some weird sign I don't understand. The 1980s, okay. Right, so that makes it so that we can move on to the actual main course here, which is this circuit. So I should probably give you guys... We have, hey, there we go, screen capture. And it seems we have audio still. I hope we have audio. I think we have audio. So, this is an optocoupler. And all of these resistors and the transistor are wired up in a particular way. This is a board I did a few days ago. And all the way over here we have a capacitor. That's and resistor, that's also important. But this is the interesting thing we're working on. So let's just get to installing this. We're going to mostly be working under a microscope. All right. I have my optocouplers here, but we need to start. Oh shit, we're not even ready to get there yet because we have another couple of capacitors to replace. I almost forgot them last time as well. We need to replace this poor axial thing, which I have new actual things for. Actuals. And we need to replace this plastic cased ones because they always fail. Positive towards the edge of the board. This one, thankfully, we can desolder properly. So we are still more or less on the maintenance side of things. Aside from a couple of wire bodges we've installed and traces we've cut, we're still just getting this board restored from having worked faithfully for 30 years. Come on, off you come. There's so much fat copper on this board, it's crazy. It's just not melting on the other side. We need to just pull at least with the fat soldering iron because the poor desoldering pump has no chance of melting that. There we go. Now that it's already warm, we can probably suck it just fine. No, we can't. Oh, the thickness of the copper on this board is sexual. Okay. But no, that one didn't even suck properly. Jeez. We need to suck both sides of them. That's better. But this one is not evacuated yet. Oh, bloody hell, I need to actually use 2 soldering irons on that. Because it is not coming nicely. There's just so much copper on this board. So we'll get some fresh solder on there. Some fresh solder on the bottom. Heat on the bottom. Heat on the top. There we go. That's evacuated. Yonekone says, is there no room for a breadboard to mount these parts? There's no point in a breadboard, it's just needless complexity. We would gain nothing from using one. And I don't like needless complexity. I like simple things because I'm a simple man. Melatil says something about the symbol he used that I don't understand still. Sorry, I'm a lost cause. New capacitor. I need to get this stupid thing over here. Ugh. They're not over there, over there. God damn it. Stupid €3 camera mount. Just in place. These capacitors are confusing, but it points to the negative. Oh yeah, the glue. Markel van der Broek says, please allow the god to let his phone go so he can go to the printing company. I don't want to go to the stupid printing company right now. I want to get this thing done. I need to have it done till tomorrow. If I go there, I'm going to be working on it all night. Someone asks, are there 4 EEPROMs lined up on to the right? No, those are read relays. These guys are read relays and we are going to use one of them. Atta says, unleash the shmoo. That's a nice Ave reference. And solder the ridiculously high thermal mass board again. Come on. Take solder you. There we go. That's all the shmoo we're going to need for a while. Because now we've got to wipe this off, get some tape down, do some cuts, and start mounting our stuff. Oh yeah, we still need to replace the stupid red plastic cased capacitor on the other side of the board. Yeah. The plastic cased capacitor, this guy, a 10 micro, 63 volts, positive towards the connector. There we go, these guys always go bad. And I brought out a new one over there. And we need to wipe underneath it because they tend to leak slightly, so this is all going to be covered in slightly corrosive capacitor trash. No, I'm seeing something interesting. This board looks interesting. What is it going on? What's going on over here? What's going on? This has gone bang at some point. Whoopsie. They have not soldered that in right. Jeez. That's terrible. That capacitor is not soldered in. Oh, you know what? This is a revision B board. Revision C of these actually have holes for this capacitor right here. But this board does not have holes, so this is actually a factory modification. It's completely terrible. Just look, that's bleh. 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 That's terrible. Duly noted. Can't believe that's actually lasted. But we'll get the new cap over there. Whoa, 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 whoa. Schnibbedy snib. So that should be all the components we need to replace on this, unless this relay has failed, which it sometimes has, but we'll have to test that later. Yeah, now we can actually start with the modification. I have some better reference images for. As I don't need any better reference images, that's just fine. We need to start by putting some Kapton tape down. Wizim asks, how's the big battery / solar panel project going along? It's reasonable. I've made the jumpers for the batteries, so I've got the batteries completed. But I need to do a bunch of stuff like this so I can actually afford to buy some solar panels. Let's see, I need to start by scratching some trays. But yeah, regarding the battery solar panel project, it's hopefully going to be happening like this summer. I need to just save up for solar panels and build some wooden solar panel mains, because I can't actually mount it on the roof here. It's at a wrong angle. So it's going to be a bit of work. I need to build the DC breaker box still. And that's mostly it. I need to order the inverter. I've decided which inverter I want. Just need to order it still. And I need money to do all that. Why are you out of focus, you stupid thing? Good camera. So yeah, I'm working my ass off to afford that. I'm probably going to be spending, like, hopefully around... I'm hoping to cap it at 10,000 euros complete cost for everything, but... yeah, I think that's a reasonable top target. Which 10,000 euros is a lot of money, but given what we are getting for that money, it's actually quite reasonable a price. So now we need to cut the hole for the transistor. So the transistor is this is ground, and this is relay choke negative, and the transistor is going to be controlling the relay. So we need to cut this trace to allow it to do so. If we leave it like this, it's, well, if we leave it like, no wait, what have I done? Oh yeah, if we leave it like this, it's just always going to be on, and that's not what we want. So let's get cutting. Under a microscope, of course. It's where's my microscope? There's my microscope. Neuronal Axum asks, you call those small? I call what small? My stream is like, I have a lot of lag on the stream. It takes about several minutes for it to actually catch up, so I might be a bit confused about your comments, unless you're very clear in them, since they're just completely late. Sorry. Malatil asks, is it going to be an MPPT one? Of course. Like we're talking a like 8 to 10 kilowatt solar array. You don't use anything other than an MPPT regulator for that. It's going to be, I believe, an MPP solar MPI hybrid 10 kilowatt three-phase hybrid inverter. It's the green MPPT solar, the green MPP solar, a 10 kilowatt three-phase inverter. If you go on like AliExpress, you'll find it, or their websites. It's the green one. They only have one green one, the biggest of the green ones. It's like 3,000 euros-ish. Including everything. And it's like, it's a rather clever inverter. It can charge your battery from the grid or solar, and it can prioritize loading, so you can have it hooked up to a battery bank in solar, and while the sun is up, it powers your house and charges your batteries from the solar panels. When the sun sets, it will run off of battery until a preset battery voltage is reached, at which point it will switch to powering the load from the grid for the remainder of the day. And once the sun rises, it's going to charge your batteries and power your load from solar again, and rinse and repeat. So you can basically set how deeply you want to discharge your batteries every day before it kicks into grid backup. It's basically reverse UPS. It seems to be very good. Like. Scratchy, scratchy. Ah, where's that focus gone? Probably into my hair. Lift what trace? I don't want to do like trace lifter when I cut them because I want a clean, nice clean cut. Someone says, wouldn't it be cleaner to use a Dremel or likewise to cut the trace? No, Dremels do a horrible job compared to cutting it with a blade. It goes quicker, but it just gives you a big gorge full of glass fiber, dust and crap. This is by far the cleanest way to do it. And that should be the last of the trace cuts. We still want to scratch some down here for that resistor. Like, yeah, somewhere around here. Not too critical. And we want to scratch like roughly here. And that should be our solder points. Now we're going to put some Kapton tape on there and cut appropriate holes in it. So the Kapton tape is just there to make sure we don't accidentally short anything to anything else. Just an extra layer of protection. And now we will do some cutting, and I will get a fresh blade for that. That's definitely not a fresh blade. I have a fresh blade. This seems to be a good blade. This is a good blade. Let's just like write something on this one to make sure it stays fresh. There we go. Now I won't go around scratching PCBs with that. We will just be cutting tape. love my new bench. It's so comfortable compared to the old one. I replaced my basically most this entire table like a couple of days ago, and it's amazing. There's actually a corner desk now compared to my old one, which was a straight desk, which didn't really fit in here. And having a corner desk it gives me so much more space to actually have a microscope and stuff on. It is glorious. I wanted a corner desk for like years, but they're so expensive. But I waited and waited and waited, and finally I got this one for free. That's the thing about life. If you wait long enough, you get anything for free. Robin, are you starting to sing All Star in my chat? I don't know the lyrics off the top of my head. Somebody once told me something, something, something. I'm the sharpest tool in the shed. I actually listened to that song last night. The band that made that song, I don't remember what they're called, but they're actually pretty good. I liked the whole album of that song. It's overlooked just because of Shrek memes. Okay, so now we can install our fancy optocoupler. And you will notice that these are not just modified dips, they are actual surface-made components. Because I knew I was going to be doing this. Let's get the picture in here so that you can see what I'm trying to do. Let's say it's window capture free. Yeah, there we go. Which camera are we obscuring? That one. Let's obscure that one. And move down. No, stupid. There we go. Beautiful. Let's just sing All Star together. All Star lyrics. Somebody once told me the world is gonna roll me. I'm the sharpest tool in the shed. She was looking kinda down with her finger and her thumb in the shape of an L on her forehead. Well, the years start coming and they don't stop coming. Offended to the rules and I hit the ground running. Didn't make sense not to live for fun. Your brain gets smart but your head gets dumb. So much to do, so much to see. So what's wrong with taking the back streets? Give me $10 and I quit. And let's give a proper tip on the soldering iron. You'll never know if you don't go. Go! You'll never shine if you don't glow. Hey now, you're an all-star. Get your game on, go play. Hey now, you're a rock star. Get your show on, get paid. And all that glitters is gold. Only shooting stars break the mold. It's a cool place, and they say it gets colder. You're bonded now. Ah shit, I forgot the melody. Okay, no one's gonna give me money, let's just do this thing. But yeah, Smash Mouth, not actually a bad band, I like them. Focus. Focus. Ah. Jeez, the copper on this board is crazy. There we go, that's stuck down well and good. Now I actually need to get rid of Smash Mouth's lyrics to Simple Picture. I don't see YouTube, I bet everyone just left when I started singing. So we'll start with... Oh yeah, I should probably get my resistors as well. So that's a 220k of when you jumper from the left side of that optocoupler to the trace up there. 220k. It's red, black, red, right? No, red, black, orange. Red, black, orange. We need one of those. We need two 120, 130Ks. Do we have 130Ks? We might. That's a 220K. We want brown, orange, black, orange, brown. 130k. I just want to use up all my 130ks because they're stupid. Not because they actually have to be 130. Here's that. That's 130. And 130. And we want a 1 meg as well. And then we're done. That's all. $1 million ohms. That's a yellow, right? Yeah. Someone says, I hope you can make a better job of one of a photo. That's actually completely fine. It's gonna look pretty much the same. There's nothing wrong with that. It's so tiny that it's not gonna move, and I'll glue it down when I'm done. So I want for 220k. Robin Vandernight says 130k, that's an odd one indeed. Yes, like a resistor kit I bought many years ago had 130k instead of 120k. For some stupid reasons I've used 130k in all kinds of stuff. It doesn't matter. In this application, the only reason we have the two 130k resistors, they are cutting the 24 volt power supply in half for a voltage divider. Just because these optocouplers can't handle 24 volts over the output transistor. They only go up to 18 volts. So the value of a voltage divider resistors really don't matter. I just took 130k because it's enough. My letter says, I just think the circuit looks messy. Yeah, it's because it's just a bunch of components with no PCB. Point to point soldered, it's gonna look a bit messy. But it's mechanically sound and it's reliable. And it's since this is such a tiny run, it doesn't make sense to make PCBs and stuff for it. And a PCB would just be a bother because it would take up extra height. It would be more difficult to install. Someone with Russian letters in their name says, "You're under arrest for over-soldering." Bigger the blob, better the job. There's no downside to having a big blob here. As long as you don't like make it so big that it turns into a ball that's going to fall off. So that's a 220k. Now let's see what we want to, what our next move is going to be. Yeah, the one thing that's a bit annoying is the resistors. Oh, I can't see the maze pointer and they're so tiny. But the resistor going to down across, that one's just kind of jumping over everything and there's just no space to really put it anywhere else. And I think we're going to have to do it that way again. We do need to we should install the 1 meg pull down resistor, which goes here before we install anything else. So I'm going to do that because I forgot it when I did the other one and just had to add it as a final thing. I had forgotten to draw it in my schematic when I originally created this modification. So we're going to be adding our 1 meg pull down resistor. So this pin here is the output of the optocoupler. That goes to the base of our BC546. And this over here is a ground, so we're just putting a 1 meg ohm to ground. Let's see if that's going to stay in place when we solder it. I doubt that, but we'll give it a go. We're optimistic today. I haven't gotten a phone call that I have to go, so we have reason to be optimistic. Oh look, it went beautifully. Did I move an inch? Well, a millimeter. Well, a micron. And now we might, let's see, I'm gonna have a quick look at the schematic. We want to have the emitter of this goes to ground, and we have a, it's the 120k, 130k pull down for the voltage divider. We want to have that go to the same point as the 1 meg pull down for the transistor. So that's going to be a 130k going over here, like so. And of course I shouldn't have soldered that over there because we have to put more stuff on there. So let's get rid of that. Whoops. How absent-minded of me. Go away, component leg. I don't want you. You are not wanted. There we go. And since the transistor is still going on there, we'll just solder that up top and not on the PCB. And there comes our BC546. And on this we want to put the green insulation of the middle leg, just to make it not short everything out. I want to bend the leg slightly, because these outer ones are going down onto the PCB, so often like so. That should allow it to lie flush. And the middle leg, which is the base, is getting folded up instead. And down slightly. And like there-ish, we'll just put it over there, and that should put it decently in line with the correct leg of the optocoupler. Decently so. I need to get just a tad more distance out of that. And I'm just uglily going to pull it. That works. Beautiful. You know, I don't think we need the insulation on this one, because we have so much clearance. So I did a bit of a better job with the resistors on this one. That's stupid. Why did I solder that resistor at all? This is a bit annoying, but we'll be fine. Let's start by soldering to the opto over here, since we already have solder on that pin. Malital says, see, your wiring looks much cleaner. Well, of course, every time you make something like this, you get a bit better at it. Because, you know, it's a research process. This is such a small production run that every unit is going to be a bit unique. And everyone is going to be a bit better than the last one. And we'll just make sure this leg gets properly bent down. Notice that I'm taking a lot of care not to ever put any load on any solder joint. Whenever I'm bending something, I'm always holding it or bending it in such a way that no load is being put on the actual solder joint it's attached to. Because any amount of bending is going to decrease the reliability of that solder joint. So when we have this, you can see it's hovering above. We actually need to grab it over here, lift it slightly and bend it down as best as we can to make sure it doesn't want to lift off of the board. That's slightly better, but I don't think we're going to get it perfect. And that means we're now going to solder these two. And once we're done, we're going to resolder this one, because that one's going to be under load, since we're going to force these components down to solder them. Someone says, you forgot for sleeving. No, I'm intentionally leaving it out because it's not necessary. This design, due to the way these are rated, no, there's no risk of them shorting out. You'd really have to mash this very hard to get it to short out. So I'm not worried about that anymore. Push that down. Oh, this copper, the copper's so hardcore. It just sucks off the heat. And we'll resolder this because this is going to go ping. I didn't, it's resting against something. Okay, good. It didn't really need the sleeving even on the one on the picture. I just put it just because I was working a bit. I was doing work under this leg on the other one after it was put in place, and I didn't want to accidentally solder something to it because that's just a big mess. And on this one, the highest point under the floating leg is the resistor. So if this gets pushed down, it's going to come to rest on the resistor. It's not going to short out to there. But I think when we're getting done, I'll just put a bit of Kapton tape in between there just to have something, just in case someone drops the board or something, so it doesn't get destroyed. Now we need to put a jumper wire between these two pins, because this is the input to transistor, the first transistor of the optocoupler, and this is input to the second transistor, since it's a Darlington design, and we want to have feed both transistors power So we're just going to jump something straight across there. And then from that jumper we're going to solder our final 130k pull down resistor, just because that's the easiest way to do it. So where's my wire? We could use a component leg for that, but since we're big budget, I'm going to use some actual wire. Big budget, yo. Poor tweezers. At least we're wrong tweezers, never not. They're the right tweezers for the job. So much to do, so much to see, so what's wrong with taking the back streets? And I genuinely like that song. It's a good song. I generally like the genre as well. Is that okay? Ah, that's beautiful. Perfect. No, stay. That's bent all wrong. Squeezy. Shit. Don't run away, this is your destiny. Bendy. Perfect. Within tolerances. We need to solder this end reasonably quickly so it doesn't desolder itself instantly. Beautiful. So that's power supply for the collectors of the double transistor photocoupler. And now we need to have a divider resistor from here down to ground. And then this circuit is pretty much done. This is going to be the ugly part because we kind of need to, I think we'll just YOLO it and solder it with no mechanical reinforcement, because we can get a huge surface area if we just do it like that. So I'm going to pre-tin the resistor leg to make it solder a bit faster. Stay in place, like so. And a bit of flux on there, and we'll solder it quickly. Hopefully it won't have time to desolder itself from both the IC legs. Like so. And we'll mate those guys and it's going to be beautiful. And that is not going anywhere. That's my have. Ah, shit. There we go. There's a positive pressure down there, so that's going to be good for reliability. A bit of extra flux on there to make it a bit better still. There we go. And that's hovering a good distance above everything here. So there's no risk at all of shorts. And I think I'll put just a tad of extra solder on here just to have it perfect. And that should be all. Let's see if we can get a good angle on the wider camera so we don't have to look through the microscope. You guys get such a tiny viewing angle on that. Let's see what we got. No focus. Are you going to focus or will you just fail? This will clearly just fail, so I'll just have to put this in telemacro mode. Boosh. You can zoom out slightly from this, but not enough for it to matter. I think something like that's the best we're going to manage. But that looks reasonably similar to the other circuit. So we have this resistor running to the second topmost pin there. The other middle pin is going down to this trace. The top and the third pin are hooked together with a resistor 130k going down there. I'm going to cut that leg. We have one 130k going to the transistor. We have the base of the transistor going to the last pin there. I do believe this should be fine. Malital says, can you test it? Yes, I can, and we will. We still have one more modification to install though. And that's the output filter in the other end of the board. This thing. So I need to mark up the pins for my own convenience. Yeah, industrial dirt. 1, 2, let's just do it, 3, 4, 5, 6, 7, 8, 9, 10, 11, oh, hair, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. That should be pins 14, 15, I believe. Let's verify. 14, 15, and this is the circuit. Very simple. Capacitor, resistor. Both are start with 2, 2, so not difficult values to remember. And I've ordered specific parts for this because they're reasonably. It's like an 80 VPP square wave. So we need some reasonably heavy duty components to handle that. I need to take a quick bathroom break. What's this say? Nothing. BRB screen. Okay, back in a second. We have returned. Hello. So now we're going to be installing the 8-bit filter on pins 14 and 15. I'm just putting some fresh solder on to suck this off, because I don't want the old solder there. I want to clean this area as well, because we want to put a bit of glue on there to hold it in place. Yuck. So we want to bend this like so, and down. Now, if I'm not bending it right where it enters the capacitor, I'm bending it along the leg. That's going to go there. We actually need to bend this leg up, because we can't really fit the resistor otherwise, like so. I want one leg of this to get straight down. Like so, and now bend that straight to the left. No, right, sorry. Beautiful. And where those meet, we'll just flip this around. Like so. Yeah. Let's get this slightly further back, just we have a bit more surface area for the solder to grab onto, and squeeze it together just a smidgen. So it's just kind of squeezing the leg of the capacitor. Beautiful. Now we'll just put some glue on there and solder it all together. Right, need to cut the excess leg here to stop it catching on stuff. That's much nice to work with. I still need to bend this back a bit. resistor so long compared to the capacitor. Okay, that's beautiful. I'm quite pedantic about there being a reasonably good mechanical connection before I solder it. Solder is like hot glue, you can't just rely on it, you need to have something else ever so slight to help it out, or it's going to give you a bad timing break. We can get this ever so slightly further back. There we go, beautiful. That's exactly how I want it. Maybe we can, yeah, even better. Perfect. That does need more solder. The crazy amount of copper in the board did not allow it to take properly. But there we go. That's in shape. And that's in shape. I'm just quickly going to inspect that under the microscope, make sure it's not terribly broken. And no, it's absolutely beautiful. And now I want to do the next thing on the maintenance list, and that's resoldering the entire connector. Because as you can see, if you've got keen eyes, some of these solder joints are starting to show age rings. This right here is a crack that's developing, very common on solder joints as they get older, and if you don't take care of these, they will lead to solder joint failure. You can quite clearly see how that is opening up. Now that is no good. No good at all. And this is just a question of pumping it. We don't need to remove all the solder, just enough that it doesn't turn into a huge, ridiculous excess. So I'm not gonna, we're not evacuating the holes to replace components, we are just getting rid of excess solder. I know that this glue I'm using doesn't really care about temperature, thankfully. If you really keep a soldering iron on it, it turns brown, but it doesn't even turn conductive. It's very good. Oh, that one did not go. There we go. Now I'm actually going to swap tips on the soldering iron because this tiny one just has no chance of actually soldering these properly. Someone says Rossman is live too, stealing my viewers. Fair. Haven't you seen enough MacBooks already? Stupid cult of personality. If I had to choose between a MacBook and a printing press, I know what I'd choose. I don't even know how many viewers I have. I don't really care, to be honest. It's going to be like 5. 29. It's all right. 29 people with better taste than the rest. Live streamer Rossman's cat. Is there at least like voiceover? Put a bit too much solder on a few of those. On this board we really need to heat the solder joints up quite a lot due to the heavy nature of the copper. Meow. Meow. Viewers, please. There we go. And I also want to redo a few more solder joints on these big rectifier diodes over here. Because they're big and heavy and get warm. Get warm. They get warm. And big heavy warm things have tendencies to fall off boards. I'm so happy that my phone hasn't rang. I told them to just run a calibration of the machine, see if the issue goes away. I hope they did that and it just went away. Tomorrow I'm going to find out. This whole board is a bit silly because it has two giant 10 amp rectifiers and like 12,000 microfarads of rectifying capacitor. But the point of this whole project we're working on is to remove unnecessary tech from these brake controllers, because they supported a bunch of other features which are no longer used, and the other features are causing the devices to not work right and cause a bunch of problems. And this power supply board is for all of that stuff as well. So this thing probably uses like 10 watts now. Well, a bit more. Maybe... No, you know what? So actually, this thing powers the whole brake thing, so no. It's going to need a lot of power. It's going to need a fair amount of power. Actually, disregard everything I just said. Let's see, what are we missing? Oh, hot. Oh yeah, the power resistor has to be resoldered. The resistor of power. Oh yeah, let's not crush our beautiful new circuit. I haven't installed the anti-crushing thing yet. Let's be careful. And I want to resolder the fuse holder. That's right. I want to check on that terrible capacitor we saw at the beginning. That's a fuse holder resoldered. And I just want to like resolder that cap. But we need to install a little anti-crushing thing for this. And let's see. So we have grind on this big thing. I'm just going to scratch some off here and put a wire jumper there. That way it doesn't get crushed when you put the board down on its belly. Let's do it. There-ish. Let's get some wire. So we want it yay high. That's definitely tall enough. I don't want it quite that tall actually. Let's cut down ever so slightly. But just kind of pulling it. That's better. Yeah. Beautiful. Maletil, how the heck is your name supposed to be pronounced? No, asks, do I use any kind of thinner for flux cleaning? No, I use no clean flux. and I've been using this particular flux for a while, and it's never caused any issues. So unless it's strictly necessary, like if I need to glue something on top, I don't usually clean this off. I'm gonna buy an ultrasonic this year though, so I guess I'm gonna be cleaning boards a bit more, just because I can easily do that. Malital says, I've used some thinner originally intended for art and such, and it doesn't really work. Just use isopropyl alcohol. Isopropanol, alcohol. Isopropanol, alcohol. 100%, 100%, 100%, all you ever need. Fat tip, much heat, very solder. Very solder. Beautiful. So the only thing that thing does is make it so that if you plant the board with this side facing down, it can land on this rather than this. This is going to be potted in glue, so it doesn't quite matter, but it makes it easier to work with. Right now, for instance, that works just fine. It's not crushing. I think that's basically it. All we need to do now is test this. See if the relay still works. I want to check the solder joints on these big breakers just to make sure they're fine. Besides, it will just resolder the breakers. It takes no time at all. You can. This board is emitting that old solder smell. It's beautiful. Probably very toxic. Such exciting work, this. There we go. might as well resolder the big relays while we're at it, just so it's done. I don't want to see this board again for like 30 years. I don't even know if these big relays do anything. I don't think so, actually. That's looking pretty alright. I want to resolder a small connector over here as well. Vladimir asks, why are you reflowing these joints? Because they are 35 years old, well, just 30 years old, and they are big, heavy components. And solder joints holding big, heavy components often fail in time. And my job is to make sure this thing runs fine for at least another decade. So we're going to be reflowing all kinds of things. All kinds of things. See, I'm a big fan of preventative maintenance. I don't like waiting until things break to fix them. There we go. That looks fine. Okay, we are ready to give this a test. So this circuit we can't test because we need a bunch more stuff to do it, but it's just an RC filter, it's going to work fine. But the optocoupler trigger we can indeed test. So I have seen on another one of these boards the relay we're controlling had failed, so we might have to replace a relay, move them around, and we'll have to see how it goes. So let's get the test setup going. Vladimir says, that's a nice camera microscope. Thank you, but it's not very nice. It's very cheap and nasty. But I'd rather have it than not. So we need power supply on. We have 2 power supplies and 1 8-bit connector on this device. So there's going to be a shit ton of clamps and stuff going left and right while we work this. So our main power supply for everything comes in at, let's make sure I get this right, comes in at pins 3 and 4, that's 24 volts AC, but we're fine with like 27 volts DC-ish. So I can adjust that on power supply. And that's pins 2 and 3. And then we have, this is intended to have a processor board connected to that connector. We don't have that for testing purposes, but we can emulate it by putting 0 volts on pin 7 and 24-ish volts on pin 8. So we'll do, I think it's 23, that's the lower limit for that. Very low current limits of like 100 milliamps on both of them. So positive on 8, negative on 7, negative on 7. Positive on 8. This is pin 7 and 8 are, geez, why? Let's get some face action there so I can look at you guys. Pins 7 and 8 have a switch connected across them usually. Let's, yeah, this thing triggers me, sorry. Is that better? That is better. So pins 7 and 8 usually have a switch connected across them. As you can see here, this is in the cabinet. We have a switch that closes when the brake is disabled. So if we have power, 23 volts here, our relay should be maybe exposed properly. Isn't that much better? Brake off, our relay should be open. Brake on, relay should be closed. So if we have power on pins 7 and 8, pins 5 and 6, which is our relay output, should be closed. There should be continuity between pins 5 and 6. And when we remove power from pins 7 and 8, continuity across pins 5 and 6 should cease. And let's get yet another couple of clamps on there, if I have any. I need to get myself some more banana plugs, to be honest. One clamp. Can we get 2 clamps? Yes, we can. Can we maybe even get like 2 small clamps? Is this broken? Why is this all messed up? No, this looks fine. Vladimir says, well, at least you got a microscope. All I have is a hand lens, magnifying glass. Yes, I do not regret getting this microscope, but as far as professional microscopes go, they're the lowest end you could possibly get. But yeah, it's good. I'm not dissing my microscope. I love it. I just wish it was a bit better. Right, so let's see if we can manage to monger clamps onto pins 5 and 6. So there's just a closing relay output. It doesn't matter polarity on these. I see why the cover was off of this. It's completely ruined it. The plasticky thing has gone hard. Come on. That's one. I need to make a proper test jig for this at some point. Okay, 5 and 6. Let's switch to another camera. Zoomify. Zoomify, please. Okay, so this is our main power supply. Let's turn that on. And it does absolutely nothing. Do we have bad connection? Yeah, oh, I got it on the wrong. Pins at 3 and 4, not 2 and 3. Whoops. Okay, 3 and 4. So this is going to slowly charge up our big caps there. And that's all powered up. We've got some LED shining down there. And this is open. So if our relay works and our circuit works, this is going to go closed when we press this. Is that not a thing of beauty? It works perfectly. First try. So if now our brake switch is engaged, relay is open, and now I go into the box, clonk. So the point of all this is, you can see the burden current on this is basically nothing. And that's because if we have the keen viewer might have noticed that what we've basically done is just make a relay. When we apply power, the relay clicks. And the reason we haven't just put the relay coil straight across pins 7 and 8 here, which go to our trigger, is because the burden current of a relay, even if it's just 11 milliamps, is too high. So it will trigger as a closed switch, even if it's open. So the total burden voltage of this relay driver circuit is about a milliamp, less than a milliamp. And yeah, that's good. Worked first try. That's more than I could say about the last one. How satisfying. The last one actually had the relay we're powering. This small one over here was actually broken. It would not make a connection, even though it's a read relay, which are usually super ultra reliable. It was just broken. The coil was open circuit. In fact, I have it here. It's dead. But that's it. We're done. Oh yeah, we need to clean up around this capacitor down here. But the big attraction is the relay circuit. That's working beautifully. Absolutely gorgeous. So we can disengage this. Do notice, by the way, this amazing power supply mount. This desk has this raisable monitor mount, so you can adjust the height of this section here. So just taking it down a bit, so this power supply is aiming straight into my face, and it's sexual. Vladimir says you should have replaced all the relays. I disagree. If read relays usually do not need to be replaced. None of the other relays, I think, do anything. And I think some of them might even be unobtainium, so it would be a bother. I'm going to try and source as many components as possible for this, because it's going to be my problem if this thing breaks down. But we actually have quite a bit of trash boards from this machine. I can show you one of them, because we're roughly 80% of this machine is getting torn out. So we have a shit ton of stuff like this, which is a gold mine for spare parts. This has diodes, this has relays, everything. So we have a shit ton of spare parts at hand. Again, I'm going to probably source a few of these relays just in case, but since they've worked for 30 years, they've worked in my application for over a year by now. You know, I strongly doubt any of them is going to fail. And the read relays, you can make it completely without them. The only functionality you lose if one of the read relays break is the ability to see if the brake is on or off. All it does is flash a light on the control panel. It doesn't even stop the machine from running, which is pretty stupid, since you can accelerate your giant 2-ton roll of paper to 100 kilometers an hour and have no means of stopping it if this board is not powered on properly or broken. So a bit of a design flaw there, but oh well, not my problem. The guys running these machines are used to that. It would probably be rather terrifying having one of these giant paper rolls just spinning out of control, because they are proper big. Like they are, if you lay one down, it's like this tall, just a giant roll of paper. So now we just got to pot this stuff with a bit of glue. I don't want to completely encase it, just to make it easy to access if it has any issues. Alphonse Jean is asking why the massive teardown, downsizing or upgrading. The machine, when they got it, they could only buy it with the feature to swap paper rolls during operation. Like while it's got the rolls going at 100 kilometers an hour, it could automatically cut the paper from one roll, swap in another one, accelerate it, and start feeding paper from another roll with no interruption. And since we live in such a tiny place, they don't need that. A single roll lasts forever. And the technology that enables the roll switching is super advanced from the 70s and buggy as hell. So it keeps breaking and causing issues and crashing and just being a general mess. So they hired a guy to just come and take as much stuff as possible out, and that guy hired me to come and take as much more stuff as possible out, and that's what we're doing. So this board is replacing like 4 other boards by just doing this. It's just optimizing the machine for the application. When you buy something like a printing press, they don't, they think they only sell the big model. There's no printing press light. That's just the big boy machine. Ah yeah, there's one thing that we shall not forget. And that is the label. Since we currently, while we're doing this work, we have several modified boards, several unmodified boards. It's important to mark them up. Oh god, shit. I had 2 labels queued up. What must this is? We don't need this to be a modified board, it's just a modified board. Yeah. Modified. Yeah, the capacitor. A messy capacitor that the factory did not get right. Oh yeah. Microscope, please. That's so bad. Ah. Christian Ivarsson says, "God kväll. Kinda like the label. It is after all modding by the guy hired by the other modder. Indeed, modception." So I just want to, like, solder that pin, which is obviously not soldered, but has lasted for 30 years anyway. Kväll? Nej, nej, nej. Afton, säger Majcherek 128. I min åsikt så är det faktiskt natt. Klockan är 1:07 på morgonen. Probably want to have a bit of flux there because we don't want to heat a lot of the breathing soldering iron fumes, although that really is not attached at all. So let's just quickly solder this without melting everything. There we go. Well, that's nice, stuck in place. Vladimir says, "This reminded me that the relay that turns on and off one of those heaters on my central heating system is not always working." Well, rip. Enjoy having no heat. Let's just do the other side as well, just because it's probably seen a bit of flexing over the years. Will this work? Yes, it will. There we go. Beautiful. Mucho happier. How nice. They're pretty much done. I want to mark out the pins on everything here like I did on the other one. Where's my pen? Brake monitor circuit. I just have a bunch of labels here for future reference. Brake monitor circuit. This is ground. This is brake switch plus. And brake switch plus is pin 8. And brake switch 0 volts is here. Pin 7. And the transistor is a BC546. And this is K5 negative. And this is plus 24 volts 2. Now we have plus 24 volt 1 somewhere, I think. Oh no, that's brake switch positive. And we have a K5 plus over here. And 220 nano 22 ohms. Christian Everson says, where do you find the good stuff? I presume you have the same problem over there. Impossible to buy leaded solder. I haven't bought solder for a long time. I'm not looking forward to doing that. This is like 6337 Crystal 400 from, I don't know, 2 years ago. I think I got it from PCBsoldering.co.uk, but guess we're gonna have to learn lead free. So it's time to document this, take a few pics. This is board number 3. It's 2020. 2020-01-19. Number 3. Picture time. Ugh. Human noises. No card in camera. Well, that's bad. That's probably over here. There we go. Pics taken. Okay, I think we are pretty much done for tonight, and thank God my phone didn't ring. I didn't have to go today. I'm gonna have to go tomorrow instead, but oh well. That's that. I get to sleep before then. So yeah, we're going to round this up. The stream is going to end quite soon. When exactly, I do not know, since I don't understand how YouTube works. But within the next minute or so, I will bid you farewell. This is where you should have some like newscaster thing where they just pan a camera around. Where the hell did YouTube go? There it is. Goodbye.